In this video, we are going to be mixing it up, which means we're going to have to decide which conversion factor or conversion factors we're going to need in order to get into moles and out of moles as part of our learning objective for applying stoichiometric relationships to calculate amounts of substances involved. So here's an example problem. It reads, a large block of copper is added to 700 milliliters of a 0.5875 molar silver nitrate solution in order to precipitate all the silver through a single displacement reaction as shown below. If all the silver produced is collected and melted down to form a solid chunk, what volume would this chunk of silver occupy? So we are given information about this substance, which is 700 milliliters of 0.85. So I know that this must be a conversion factor. That's going to help me get into moles. So my first thing I'm going to need to do is use my molarity to help me get into moles of this substance. But then it's asking me to find amount of this. And it's asking for volume of this, but I don't have a different molarity to use. So let's think about this. This is a solid piece of silver. It's not a solution, so molarity wouldn't help me anyway. But I do know the density of silver can help me relate the mass of that solid into the volume of that solid. So I'm going to need the density in order to go from grams of that substance into centimeters cubed. But I need to get into grams from moles. And so to go from moles to grams, I'm going to need the molar mass. So I'm going to need both molar mass and density. So I'm going to use molarity to get into moles. Then I'm going to use the molar ratio. Then once I'm in moles, I'm going to use the molar mass and then that. So the molar mass of silver is here. So those are the two pieces of information I think I need from that table. So let's go ahead and get started. So that is 0.700 liters of the AgNO3 solution. I need to cancel out my liters of solution to get into moles of the solute. That's going to be 0.5875 moles per 1 liter. Now that I'm in moles, I need to change substances using my molar ratio. And so that is going to be a 2 coefficient there and a 2 coefficient there. And then I need to get out of moles. And first I'm going to get into grams of silver, canceling out my moles of silver. This is going to be my molar mass. And that's going to be 107.87 grams per 1 mole. But I'm not in the unit it's asked me for. It asked me for centimeters cubed. So the density is 10.49 grams of silver metal for every 1 centimeter cubed. And I don't have any more room, so I'm going to have to go up a little bit. Alright, so that's 0.700 times 0.5875 times 2 divided by 2 times 107.87. That's not stupid calculator. Delete. 107.87. Alright, So that is 44.36. Let me make sure I typed everything correctly. Oh, I haven't divided by the density yet, have I? See, always good to double check things. And then we need to divide that by the density, 10.49. And so that is 4.2289 centimeter cubed. And I need 1, 2, 3 sig figs, because 3 is less than 4. And so that's going to be 4.23 centimeters cubed. So our chunk of silver metal that we would precipitate would have a volume of 4.23 centimeters cubed. Here's a practice problem for you. It says how many molecules of O2 are required to fully combust 1.25 moles of butane. Go ahead and pause the video and try to work this out on your own, and then unpause the video when you're ready to continue. Okay, so let's go over this. We are not given the chemical formula of butane, but we can decipher what its chemical formula is from our organic chemistry nomenclature. But means 4 carbons, and since it's an ane suffix, that means it's going to follow the 2n plus 2 rule, which means it's going to have 10 hydrogens, because 4 times 2 is 8, plus 2 more is 10. So we need to write a balanced chemical equation for this process. C4H10 plus O2, this is combustion, and so that's going to form carbon dioxide and water. So I'm going to balance my carbons first. That's a 4. Half of that is 5, which is an odd number, and so that means I'm going to end up with an odd number over here. And so instead I'm going to double this. That way I'm ending up with an even number coefficient for the hydrogen. That will help me. Okay, so that's going to be instead an 8. Now this will be a 10. Now this is going to be 16 plus 10. That is 26. 26 divided by 2 is 13. So now I have fully balanced my equation. And so I can begin to calculate it. So the first thing I need to do is always get into moles. But I'm already given moles, and so I am done with step 1. I am already in moles. And then we need to change compounds. We need to get into that. So we need to cancel out moles of C4H10 and get into moles of O2. That's the 13 coefficient versus a 2 coefficient. And then what am I trying to get out of moles? Let's see. Get out of moles. So I know I'm going to get out of moles into molecules. So that's a count of molecules, and in every 1 mole of that substance there are 6.022 times 10 to the 23rd molecules. That's Avogadro's number. So now I can type that into my calculator. That is 1.25 times 13 divided by 2 times 6.022 times 10 to the 23rd. That's a big number. Let's see, can I force my calculator into scientific notation?